functions.
Oh, God.
I don't think I remember a deficit.
I'm going to be on YouTube.
I might be able to edit you out. Okay. Okay, inverse functions. What are the three words most commonly confused in math that you guys always use?
Opposite, inverse, reciprocal.
Opposite, inverse, and reciprocal. Let's go in order of what we're not talking about today first.
What about the word sign? Like sign of something?
Sign and yeah, that's mixed up a lot, but these are the three that are I hear the most often. What does opposite mean?
Like positive and negative.
Yes, opposite is where you switch the sign, Sam, not the S-I-N-E, where you switch the sign as in positive or negative.
That's an equal sign.
That is an equal sign.
It's only a while ago.
Yes. Okay. Reciprocal. What is... You don't remember what reciprocal is? I may have to demonstrate what a reciprocal is, apparently.
Oh,
Okay.
wait.
All right. Reciprocal is, if this is me, right here, okay, if this is me, then my reciprocal is this.
Walk around the room.
Oh, walking's easier. Now, turning around without killing that might be hard. But I managed to do it anyway. Reciprocal. That's a demonstration of the reciprocal. That's not a definition. Anyone know the actual definition of reciprocal?
When you flip the bottom to the top.
That's, again, a demonstration of what you do. The actual definition, I may not have given you this last year, is...
It's the opposite. Switching the minutes.
No, don't. Jesse. Oh, my God.
It's the inverse.
Don't even go there. Reciprocals are two numbers. Think about this one a minute, whose product is positive 1. Any two numbers whose product is positive 1, they are reciprocals of each other. What do you get when you multiply 1/3 times 3?
1.
1. What do you get when you multiply negative 5 times negative 1/5?
1.
1. You guys with me there? Saul, you got that? Saul, am I going to be putting something in the recycling in a minute?
No.
Good. Get it off your desk. Okay.
Maybe zoom in on Saul's.
Okay. Now, inverse, which is what we're talking about today. An inverse is when you transpose or switch. In this case, we're only going to talk about the two variables in question. Okay? World's simplest inverse equation examples. Okay, world's simplest example of this ever. Saul and I are eating, and I can't type. Saul and I are eating, where is it? M&Ms. Saul, who do you think eats more M&Ms in a hurry, you or me? You a candy fan? I'd probably do that. Okay. Saul and I are eating M&Ms.
What kind?
Plain, of course. Peanut's terrible.
Well, there's peanut butter. Those crunchy ones were pretty good when they were around.
All right. Well, this is plain, so since I'm the plain fan.
You ever get the Domino's stuffed crust? What's it called? Cheese in the middle thing.
Guys, I'm allergic to cheese, so no.
Why?
Okay, guys, we don't have enough time. Mr. B is eating 2 times as many. Okay? Now, I want to graph this. Okay? There are 2 ways I can graph
Video without sound.
this candy eating situation.
Why would you want to?
I guess I'm that bored. But I'm going to graph this one by hand.
You're not that bored. You're eating M&M's.
I'm eating M&Ms. I know. What greater thing could there be in life? Okay, so I'm going to draw this by hand. It'll be a little bit sloppy.
Where are you drawing it by hand?
Okay. Speed is all. Okay, Saul. Let's say I want to graph an equation in blue where the number of M&Ms Saul eats, okay, is the main variable. It's like the y equals. Okay? how would we represent the number of M&Ms you eat in terms of how many I'm eating? You're eating half. Half. Yeah. Saul is eating 1/2 of the amount that I am. Okay?
So can we say like one or every like 2 M&Ms you eat? For every like 5 you eat,
Or like 2.5.
That's 2.5, yeah. You can say it a lot of different ways in English, but I'm trying to graph it. Okay, now, what if I decide to make myself the main variable like the y equals? How would I write this in terms of how many Saul eats? 2s in this case. Okay, in science classes, you may have learned this already, but to review, you always pick a dependent and an independent variable. Okay? If you write it this way, you're saying that Saul, the amount of M&Ms that Saul eats depends on how many I eat. If I eat 20, he's going to eat 10. If I eat 40, he's going to eat 20. Okay, that's what this says mathematically. Might be not what be 100% true. We're probably both just lunging for him, but still. If I decide to make Saul the independent variable and say how much I eat depends on it.
No matter how many he eats, you have to eat double?
Yeah, then I'm saying like if he eats 10, I got to eat 20. If he eats 5, I got to eat 10. In each case, you get to, and now sometimes you get to pick which is the dependent and which is the independent variable. A lot of science experiments you don't. In fact, in science, what is the most common variable represented along the horizontal axis?
Time.
Very good. Time. Time is the most common independent variable, and experiments usually depend on what time you check, on how much things are boiling or expanding or shrinking or growing or whatever you're looking at. Plants, gases, boiling liquids, chemicals, whatever. So this is usually the independent variable. This is dependent. Does it have to be that way? No. René Descartes wanted it that way when he was on his mushroom trip 400 years ago inventing this stuff. But in this case, I don't think anyone really deeply cares in the scientific world whether my M&M consumption depends on Saul's or Saul's depends on mine. So I can graph this either way.
I care.
If I graph Saul in blue, okay, because he's calm, cool, and collected that way, what is the slope of that line?
Depends on
Up 1/2.
1/2. Up 1/2, yeah. Just this line. If I change these into lines, this is going to be y equals 1/2 x. Okay? Which goes through the origin and has a slope of 1/2. I'll write that as a line over here. And that's going to be a slope, somewhere down there. If I decide to graph my M&M consumption as a dependent variable in a line, what's its equation going to look like? Y equals 2x, which is going up twice as fast, which represents my superior and less healthy M&M consumption. These two lines are inverses of each other. They represent the exact same thing, but the dependent and independent variables are switched. Okay? So that you're inverting any math-represented situation when you switch the two main variables. So we're only going to use this word really in two-dimensional stuff.
Wait, so how many variables are there in this?
Only 2.
And so this happens. So you're switching. This is the red line is if you are the y-axis, and the blue line is the solid y-axis.
Correct. That's exactly right. Okay? Now what we're going to do actually is a little bit different than this. We're actually going to switch the x and y, but keep representing it on a axis where the y is up. So here's how inverse functions tend to work. Okay. Next page here. Inverse functions. Okay. To find an inverse function, we went through these steps last year, and then I'll go through some of the exceptions. To find an inverse function, 1, switch x and y. Okay?